Hello friends and welcome to Edisati. Now we'll be discussing the topic of triangles. Triangle. Three lines in a plane of which no two are parallel, neither concurrent forms a triangle. So I need three lines in a same plane. No two of them should be parallel and they should not be concurrent to each other. The closed figure which is formed is known as a triangle by such three lines. Now the lines would not be concurrent. If the three lines that you are getting are concurrent, you will have a single point. You'll never be able to get a triangle. For a triangle to exist, the three lines should intersect at three different points, which will act as the three corners of a triangle. Let's look at the properties of triangle. The basic property of triangle is sum of all the interior angles of a triangle is 180 degree. So the three angles that we have are angle A, angle B and angle C. These are three interior angles that we have for a triangle. Small a, small b and small c denote the length of the side opposite to capital A, capital B and capital C. So a length opposite to capital A angle would be represented by small a and so on. So the sum of all the interior angles of a triangle would always be 180 degrees. The next property would be exterior angle of a triangle. Now, exterior angle could be to any of the angles. If I draw an exterior angle to angle C, this will be an exterior angle C. This will be exterior angle C. Similarly, if I draw an exterior angle to B, I will extend this line BC. From this line BC, I'll come back. That angle is an exterior angle B. So if I talk about A, I'll extend this line. This angle is known as exterior angle A. So this exterior angle would be equal to the sum of opposite interior angles. So if I look at it, the proof is very simple. Angle A plus angle B plus angle C would be 180 degree and C plus exterior angle C would also be equal to 180 degree. So if I just equate the two things, I'll get exterior angle is equal to the sum of the two opposite interior angles that I have. So exterior angle A will be interior angle B and C. Exterior angle B would be opposite interior angles A and C. Similarly, exterior angle C would be opposite interior angles A and B. You can refer to the figure for more details upon this. The next property of triangle is very important for a triangle to be formed. If a triangle has to exist, the sum of its two sides should be greater than the third. And this holds true for all the three sides. So if I take the sides B and C, the sum of the two sides B and C should be greater than the third side, which is A. The sum of the two sides A and C should be greater than B, and A and B should be greater than C. So it has to be true for all the three sides, else the triangle you will not be able to form. Similar property is on the difference of the two sides. Difference of the two sides, and when I'm talking about the difference, I talk about the absolute difference. It really does not matter to me which side is bigger or smaller, but the absolute difference of any two sides should be lesser than the third. So B minus A less than C, C minus A less than B, and B minus C less than A. This has to again hold true for all the three sides of a triangle. Only then a triangle would exist. Only then a closed figure of three lines would be formed in a plane. Let's look at the type of triangles that we have. Triangles can be classified on the basis of angles. That means I'm talking about angles which are interior angles that I have, as I just talked about. So sum of all the interior angles is 180. And on the basis of interior angles, a triangle can be classified as acute angle triangle. As the name suggests, acute angle are the angles which are less than 90. So an acute angle triangle would be a triangle whose all the angles are less than 90 degrees. The figure would look like this. I have three sides and I have three angles. If I just mark the angles, opposite to the sides is what the angles are marked with the similar name. So if I talk about this, small ABC here refer to the side lengths. I am taking C side to be the largest among A and C. So if if you talk about a triangle which is acute angle triangle, the sum of square of the largest side, the square of the largest side is less than the sum of squares of the other two sides. So a square plus b square is less than c square if it is an acute angle triangle. This can also help me in finding the nature of the triangle. I look at the largest side, I find the square of it, I find the square of the other two sides, I add them up. If they're coming out to be more, that means it's an acute angle triangle that we have. Right angle triangle. One angle is 90. So that means the sum of the other two angles would also be 90. So if I look at the property that I have a Pythagoras triangle where c square, that means hypotenuse square, is equal to base square plus perpendicular square. So this is a property that has been applied in a right angle triangle. The third type of triangle on the basis of angles is an obtuse angle triangle. So obtuse angle triangle is a triangle where one of the angle is obtuse. That means it's greater than 90 and less than 180. Only one of the angle can be obtuse, no, not two angles can be obtuse, because the sum condition has to be still satisfied. The sum of all the three angles of a triangle still have to be 180 degree. So at max, one angle of a triangle can be obtuse. In such a condition, this is the figure that you will get. A angle here is an obtuse angle that C angle is an obtuse angle that I have in the figure given this. So if I have to find the relationship between the side length, c square, which is the length of the highest which is the square of the length of the longest side, is greater than the sum of the squares of the other two sides. So I can just find out the nature of the triangle by looking at the formula that we have. If it is equal to, it will be a right angle triangle. If a square plus b square is greater, it will be acute. If a square plus b square is lesser, it will be an obtuse angle triangle. Another classification of triangle can be made on the basis of sides. So on the basis of side, the first type of triangle is a scalene triangle in which all the sides are unequal. That means you have all the three sides which are there, none of them are equal. A is not equal to B, not equal to C. The second would be isosceles triangle, where two sides are equal. It can be any two sides. A is equal to B, not equal to C, or B is equal to C, not equal to A, or anything. Two sides are equal and the third side is not equal. So here, these two sides which are there, let me just mark them as A, B and C. So if I just look at that, this side will be B, this side would be C, and this side would be A. So what I have here is B is equal to C, not equal to A. I have two sides which are equal and the third side is not equal. An important thing to remember is, if two sides are equal, angle opposite to equal sides are also equal. Very, very important. So if side B and C are equal, the angles opposite to equal sides are also equal. If the sides are not equal, the angle opposite to sides are also not equal. So this is very, very important thing that you have to take care while you are doing properties of sides of triangle. The third one being equilateral triangle. If all the sides are equal, the triangle is known as an equilateral triangle. So A will be equal to C, will be equal to B. If two sides are equal, angle opposite to equal sides are also equal. So A will be equal to B, B will be equal to C, A will be equal to C. All the angles are equal and all the angles turn out to be 60 degree, because sum of all these three sides of a triangle would be equal to 180 degrees is what we have. Area of the triangle. Now there are various methods to find out the area of the triangle. Which method to follow will depend upon what is given to you in the question. So the first formula for finding out the area of the triangle is half into base into height. So whenever I am talking about the height, in case of geometry, I always talk about perpendicular height. So let's look at the triangle which is given to us. This is a triangle which is given to us with sides A, B and C. I am talking about a general scalene triangle, not a case of isosceles and equilateral triangle. So in general, if I am looking at this, if B is taken as the base, the height or the perpendicular distance is always from the opposite vertex. So it will depend upon which side I am taking as the base. I am taking any of the three sides as the base, and I will get corresponding values of height. So if I take A as the base, a perpendicular distance from this angle would act as a height for A as the base. The other formula that you can use is a Heron's formula. Now what's the formula? S into S minus A, S minus B, S minus C whole square root, where S is the semi-perimeter. Perimeter is sum of all the sides. Semi-perimeter means I'll divide it with 2. Not by 3, it is not the average. It is the semi. Semi means half of the perimeter. This formula can only be applied if all the three sides are given to you. So if A, B, C are given to you, you can find out the value of S and put into the formula, and you can get your answer. The third formula that you can use to find out the area of the triangle is half AB sine C, or half BC sine A, or half CA sine B. It will depend upon which two sides are given to you, and the angle which is there is the included angle between the two sides. So if you are taking sides A and B, the included angle between them is the C angle. I have to take the sine of the angle included between the two sides. So if I am taking B and C, I look at the sides B and C. There is A angle which is included between the sides B and C. So I will take sine of the included angle between them. If the sides are A and C, there is a B angle which is formed inside A and C. So I will take sine of the included angle between A and C. Now this formula is very simple application of trigonometry. How it is derived? Just let me explain you this. So this is the triangle that we have, ABC. Okay, I'll just assume these sides as A, B and C. Now if I draw a perpendicular from here, what will be there? This will act as a height. This will act as height to me. And this angle is given to you, B. Okay, so what is the basic formula that you have is half into base. The base here is A, and the height that I've taken is on opposite vertex is H. Now since H is not given to me, I can look, I'll just mark this point as D. I can look in triangle ABD. If I just look at this triangle, sine of an angle is perpendicular over hypotenuse. Perpendicular is H and hypotenuse is C. So H can be written as C sine of B. So I can just find out the formula. I can put this thing back and I will get the formula as half AC sine B. This is not a new formula. It's a simple application or extension of the original formula that we have. There are two more formulas for finding out the area of the triangle. For the time being, you can remember the formula. I'll explain you in detail as we move further. Area of the triangle is also given by R into S. S again here is the semi-perimeter, which has been found out by finding out the perimeter and dividing it with 2. R is in radius. In radius is the radius of the triangle in which a circle is formed. So I have a triangle. If I am able to draw a circle inside this triangle that touches all the three sides of the triangle, the radius of such a circle would be known as in radius. The last formula that we can use is the formula ABC over 4R. Now ABC are the product of the three sides of the triangle divided by 4R. Now R here is the circumradius. Circumradius is the radius of the circle which is formed outside the triangle, touching all the three vertices of a triangle. So if I just look at here, the radius of this circle would be known as circumcircle. The radius of the circle which is formed inside the triangle is known as incircle, and which is formed outside is known as circumcircle. So if I talk about this, the radiuses would be in radius and circumradius. So These are the two formulas that will be used when in radius or circumradius is given to us. Let's look at the properties of triangle. Triangles on the same base and between the same parallel lines are equal in area. Very important property. If you have a number of triangles on the same base and between same set of parallel lines, if you remember the concept of parallel line, the distance between the two parallel lines would always remain constant. Now what I do is, if I take the same base, so that means my base is same, I follow the formula half into base into height. Now if you look at it, the triangles are formed between the same set of parallel lines. So that means between AB and the other line that you have, between, let me call them as L1 and L2. Between L1 and L2, the perpendicular distance always remains h. That means irrespective of the points that you take, it will always be h. So if your base is same, irrespective of the point that you take, the perpendicular distance will come out to be same, and therefore the area would be same. So area of the triangle AC1B, ACB, AC2B all will turn out to be same because their base is same and their height also comes out to be same. So ABC1, ABC2, all the formulas will give you the same answer because it is half into base into height, which is constant whenever you have a perpendicular, whenever you have a parallel line. Let's look at some of the other properties of triangle. Sine rule. The length of a side of a triangle is proportional to the sine of the angle opposite to it. Now what does this mean? The length of side A would be proportional to the angle opposite to it. Opposite to side A, there will be an angle A. That's why we have named them like this. So A will be proportional to sine of the angle opposite to it. Similarly, B will be proportional to sine of the angle B. C will be proportional to sine of the angle C. And therefore, you can form the relation which is, if I just remove this sign of proportionality and equate it with the sign of equality, I'll have A is equal to K sine A. Now this K is a constant of proportionality that can be found out in all the cases, which will be A over sine A and can be equated because the constant remains constant. So the formula that I have, which is a very important formula, A over sine A equals to B over sine of angle B equals to C over sine of angle C. And all of these values are equal to a constant. Now this formula is used extensively when you are solving your questions on triangles. Whenever you have to find a relationship between the sides and the angles, when some of the angles are given, you have to find some of the sides, or vice versa. So you can always put the values in this and you can get your result. The other thing which is there is a cosine rule. Now this cosine rule will help us in finding out the angle if all the three sides are given to you. So I can look at this as cos C will be equal to A square plus B square minus C square over 2AB. So this is the formula that I have to remember. If I am finding the cos of angle C, the side opposite to C is small c, which will be written in the last in a negative sign, and both the other sides would be taken in the plus sign. So it is A square plus B square minus C square over 2AB. Again, a very important rule that we have. If you are not able to solve the question using a sine equality, you will have to use a cosine formula to solve the question. Let's look at the case of an isosceles triangle. As we have already discussed, in case of an isosceles triangle, two sides are equal. If two sides are equal, angle opposite to equal sides are also equal. So if I look at the case, this is an isosceles triangle that we have. This side and this side. So if you talk about this side would have been A, this side length would have been C, but this is also equal to A because the two angles A and C are equal. It's an isosceles triangle which is given to me. So these angles A and C are equal. B angle is different that I have. A property of isosceles triangle is the height of an isosceles triangle, or the altitude from the opposite vertex, bisects the base. The proof of this can be understood with the help of congruent triangles, which we'll do in some time. But if I look at it, this base, which is the side B, would be divided equally. So whatever is your altitude, that also act as a median. So if you have some confusion in what is an altitude, what is a median, just follow through the presentation. You will understand it in great details after 5 or 10 minutes. So if I just look at it, here AB and BC are equal, therefore angle A is equal to angle C. So if I look at it, both the triangles would be taken as congruent. If the two triangles are congruent, then this angle would become equal to this angle. The sum of both the angles is a linear pair. So this angle and this angle both turn out to be 90 degrees. This turns out to be a right angle triangle. In case of a right angle triangle, Pythagoras rule can be applied, and what I have is BD square plus CD square is equal to BC square. So this is basically, I have the value of A square plus CD is B by 2 whole square is equal to BC square. This is BD. This is BD square. This is H square is equal to A square that I have. Okay. So I can just rearrange the terms and I can get the value of height or altitude. That will be A square minus B square by 4. Area, again, if I have to find out for an isosceles triangle, it will be half into base into height. The base here is B and the height here is BD, which can always be found out by using a Pythagoras theorem. In radius and circumradius is what we have discussed a little earlier. In radius is the radius of a circle which is formed inside the triangle. So I'll just draw a rough circle inside this triangle. So if I draw a rough circle inside the triangle, a circle, not exact one, the circle would look something like this. In radius is the radius of this triangle is equal to 1/3 the height. So if the height is 3, this will be one part, this will be one part, and this will be the third part. So it is actually divided into 3 parts. Circumradius, the radius of the circle which is formed outside the circle, outside the triangle. So if I just go ahead and form a circle outside this triangle, it will be a circle that I will get. Radius of such a circle is known as circumradius, and this will be equal to 2/3 the height of a isosceles triangle. Equilateral triangle. We've already discussed an equilateral triangle is a triangle whose all the 3 sides are equal, and therefore all the 3 angles are equal, and all the angles are equal to 60 degree. Let's discuss it in a little bit more of detail. So if I look at again this, ABC is an equilateral triangle, all the sides are A. If I draw a perpendicular from B to D, this perpendicular would be dividing the base into 2 equal parts. This triangle and this triangle would become congruent to each other, right? So if I just follow in the things, I would get the value of height. Again, this value is obtained by Pythagoras, which is A square is equal to H square plus A square by 4. So I can just subtract the thing. 3A square by 4 is equal to H square, and the value of H that I will get is equal to √3 by A. This is very, very important. I will always remember this, that the height of an equilateral triangle is √3 by 2 into the side of an equilateral triangle. Area, half base into height. I have the value of base. I have already calculated the value of height. I put it, I get the area of an equilateral triangle. This standard value needs to be remembered. √3 by 4A square is the area of an equilateral triangle. I need not use any other formula. This formula is sufficient enough for me. Perimeter. Perimeter is sum of all the sides, would be same. Hence the perimeter would be 3 times the side. In radius again, the length of the radius of the circle which is formed inside this triangle would be same as that was in case of isosceles, which was 1/3 of the height. Here I have the formula for height, which is √3 by 2A. So I'll just put the values. 1/3 of the height. I put the 1/3 of the height. Height is √3 by 2A. So I can just calculate this. I'll get A by 2 √3. Circumradius, the radius of the circle which is formed outside the equilateral triangle, is 2/3 of the height. The height is again root 3 by 2 into a. So I can look the value a by root 3. An important point here to notice, r is twice of small r. So circumradius is double the in radius in case of an equilateral triangle. Circumradius is double the in radius in case of an equilateral triangle. Let's look at a case of a right angle triangle. Now what happens in a right angle triangle is, you have hypotenuse, you have a base, and one of the angle is 90 degrees, so that the sum of the other two angles is also 90 degree. So here in the figure that we have, angle ABC is 90 degree that we have. I can always apply Pythagoras theorem, which is hypotenuse square, which is AC square, is equal to AB square and BC square. One of them can be base, one of them can be perpendicular. The values of base and perpendicular are interchangeable. Now, there are some Pythagorean triplets that we need to remember. If we remember them, we'll be able to do the questions very easily. So there are some Pythagoras triplets which are very standard, are 3, 4, 5. 3 square plus 4 square is equal to 5 square. Other one being 5, 12, 13. That means 5 square plus 12 square is equal to 13 square. Now if you look at the two that you have, this 5 is common in both of them. The only difference being, in the first case 5 is the hypotenuse, whereas in the second case 5 is either the base or the perpendicular. 5 cannot be the hypotenuse. The third one being 7, 24, 25, 8, 15, 17, 9, 40, 41, 20, 21, 29, 11, 60, 61. So these are some Pythagorean triplets which are standard ones, which if you remember can help you solve the question very easily. And an important point to note is, any multiple of Pythagorean triplet is also a Pythagorean triplet and will satisfy the Pythagoras theorem. Now what does that mean? If I have a basic triplet which is 3, 4 and 5, any multiple multiplied with 2, 6, 8, 10 will also form a Pythagorean triplet. That means 6 square plus 8 square will also be equal to 10 square. Multiplied with 3, so 9, 12 and 15. 9 square plus 12 square is equal to 15 square. Similarly, 30 square plus 40 square is equal to 50 square, and so on. So all the multiples of Pythagorean triplet are also Pythagorean triplet. I need to remember only the basic ones. The higher one could always be found out. Now the rule to calculate the other side is as follows. If n is one of the integral side which is given to you in the question, the other two sides are given by n square plus minus 1 by 2 if n is odd, and n square by 4 plus minus 1 if n is even. So if one of the side is given to you and it is given that it's an integral side, you can always find out the other two sides by using the formulas mentioned above. The only criteria is whether n which is given to you is odd or the n that is given to you is even that you have. So you have to use the formula accordingly and to get your answer. Let me take this simple case only. One side which is given to us is 3. Now the other side would be 3 square. That means 9 plus minus 1 by 2. So 9 plus 1 by 2, 5. 9 minus 1 by 2, 4. These are the other two sides that you have. If I give you a side which was 4, the other two sides would be given by the other formula n square. 4 square 16 by 4 plus minus 1. So 4 plus 1, 5, and 4 minus 1, 3. These are the sides that I get. The last thing to note when you are talking about a case of a right angle triangle is, in case of a right angle triangle, if you take the center of the hypotenuse, you will be able to draw a circle with center of the hypotenuse as the center and half of the hypotenuse as the radius. A circle passing through all the three vertices of the triangle. That means a circumcircle. Now the radius of this circle is known as circumradius. So if you take AC, this will act as the diameter of the circle, O point being the midpoint of the hypotenuse, acting as the center of the circle. OC and OA will act as the radius, and this would also pass through the other point B. So OA, OB and OC, all of them would be equal to the circumradius, and the radius is equal to half the length of the longest side. So if I can call it as AC by 2. Okay, good. Let's look at a special case of right angle isosceles triangle. So what does that suggest? It's a right angle triangle, but it's also isosceles. That means the other two sides, which are the base and the perpendicular, also turn out to be equal. So AB and BC in the given figure are equal. If AB and AC are equal, angle opposite to equal sides are also equal. There will be 45, 45 that you have, and B angle was anyways given to you as 90 degree. Now if you join B with the center of the circle, that can be formed with O. That means taking AC as the diameter. This BO will also act as the radius, and the angles that you will get, angle ABO and angle OBC, will also turn to be 45 degrees. So Pythagoras theorem is always satisfied in a right angle triangle. I'll have AB square plus BC square is equal to AC square. Now AB and BC are also equal, so I'll have 2 times BC square is equal to AC square, and I can find out the length of AC in terms of the other sides as well. Angle A and C is 90 degree, and the length of the other side would be A root 2. So if this side is A, this side is A, this side will be root 2a. Now root 2a will be the diameter, so the radius will be root 2a by 2. Here again the thing that we have just done, OA, OB and OC will act as the circumradius. Now if I look at it here, the circumradius will be equal to half of the diameter, so root 2a by 2, or it will be equal to a by root 2. The triangles that we get here, OAB and OCB, they are congruent. So these two triangles are congruent and they are similar to the original triangle ABC that we have. We just said the two triangles which are formed are similar and they are congruent and they are similar to the original triangle just we had. What do you understand by similarity and congruency? Let's understand it in detail. Two triangles are said to be congruent if they are same in shape and size. So the things that you need to concentrate on is shape and size. That is, the corresponding sides are of same length and the corresponding angles are the same. Shape of any triangle is determined by the angles. So if the angles are same, the shape would be same, and size is determined by the length of the sides. So what is it saying? Corresponding sides are of same length and angles are also same. So both the things have to be satisfied. Two triangles are said to be similar if they are same in shape only. So that means I am only worried about the angles. If the angle of one triangle are equal to the corresponding angles of the other triangle, the two triangles are said to be similar. They will turn out to be equal if the lengths also become equal. So all triangles which have shape same are known as similar. If the lengths also turn out to be same, then they will be called congruent. So congruency is a special case of similarity that we have. Now let's look at the concept of similarity in detail. The two triangles that you can see, ABC and DEF, are not same in size, but yes, they are same in shape. What does that mean? The corresponding angles are same. Angle A of the smaller triangle would be equal to angle D of the bigger triangle. Angle B of the smaller is equal to angle E of the bigger. Angle C of the smaller is equal to angle F of the bigger. If all the three angles of one triangle are equal to the corresponding angles of another triangle, the two triangles are said to be similar to each other. If the two triangles are similar, their sides are proportional, and the ratio of the corresponding sides can be taken as equal. That means AB over DE, which is the side which is opposite to angle C and angle F, the two angles which are equal, is equal to the ratio of the side opposite to angle A and D. BC over EF is equal to the ratio of the side opposite to the third angle being equal. It is CA and FD. All the three ratios are equal to another constant K. So, triangle ABC is similar to triangle DEF. Whenever I am writing two triangles that are similar, the order matters. That means the way that I write tells me angle A is equal to angle D, angle B equals to E, and C equals to F. If I write the order randomly, I'll not be able to get the ratio of the corresponding sides in a correct manner. Congruency. The two triangles that you can see on the right hand side, this one and this one, are same in shape. That means the shape is similar and size. That means the corresponding sides are not only proportional, they are actually equal. The value of K that I found out in the last slide comes out to be equal to 1. If that happens, the triangles become congruent. If I have to prove the two triangles to be congruent, there are certain set of rules that I need to understand. The first one being SSS, that means side, side and side. If all the sides of one triangle are equal to the corresponding sides of another triangle, both the triangles are said to be congruent. That means if I look at this, two triangles, this side is equal to this side, the second side is equal to the second side of the triangle, the third side of the triangle of one triangle would be equal to the third side of the other. The two triangles are said to be congruent. The second one being SAS. Two sides are equal and the included angle between them is equal. So replace this S with A. 3S, 2S and 1A. Now again take one S out, replace it with A. 1S, 2A. Two angles are equal. The angles have to be equal and any side is equal. So I can say this side is equal to this side. This angle is equal to this angle. This angle is equal to this angle. If two angles are equal, anyways the third one would be equal because the sum of all the three angles of a triangle would always be 180. But I have to prove that minimum one side is equal. Congruency cannot be proved if I do not prove that one side, at least minimum, of first triangle is equal to the corresponding side of the second triangle. So if I have to prove two triangles to be congruent, I can apply any of these rules. SSS, all the three sides equal. SAS, two side, one angle, two angles and one side. So any of the three rules I can apply to prove the two triangles are congruent. The fourth one being, and it's not a new one, RHS. In a right angle triangle, if any two sides are equal, the two triangles are said to be congruent. This is very, very evident. Right angle matlab one angle I've already taken as same. And two sides equal, it is actually the same rule that I am applying here. similarity. If I have to prove that the two triangles are similar, I would use a similar pattern that I've just used with a little difference. SSS, in case the triangles are congruent, the sides have to be equal. In case the sides do not turn out to be equal and they turn out to be proportional, that means the two triangles are similar only and not congruent. All the sides of one triangle are proportional to the corresponding sides of another triangle. Second one being SAS, similar to what we have done. In the congruency thing, we have done that the two sides are equal and the included angle is equal. Here I would say two sides are proportional. Two sides are proportional and the included angle is equal. Third one being AAA or AA. I am not writing AAS because this S would be a redundant thing here. So I just write it as AA. If two angles of one triangle are equal to the corresponding angles of another triangle, third one would obviously be equal, and therefore I'll have all the three angles of the first triangle equal to the corresponding angles of the second triangle, and no information about the sides. I would say the two triangles are similar. So any of these rules I can use to prove the concept of similarity. What happens if the two triangles are similar? If the two triangles are similar, their areas are not equal. I think this is very evident because they are not of same size. If they are not of same size, how their area can be equal? However, you can always find out the ratio of their areas. The ratio of areas of two similar triangles is equal to the square ratio of their corresponding sides. Now, what do you mean by corresponding side? Corresponding side means if angle B is equal to angle Q, so the side opposite to B, which is AC, would be related to the side opposite to Q, which is PR. That means if I say PR is twice of AC, PR is twice of AC, this too is a proportionality constant that we have. All the other sides of this triangle would be double of the corresponding sides of this triangle. So if I say angle A and angle P are same, this BC is X, QR will be twice of X. All the three sides of the second triangle would be double that of the first. If angle C is equal to angle R and I call this side as Y, this will be turning out to be 2Y. So if triangle ABC and PQR are similar, then I know their sides are proportional and the ratio of their sides are equal. So if I am taking AB over PQ is equal to BC over QR is equal to the corresponding sides is equal to the constant. In this example, I have taken the constant value as half. So I was getting this thing. So whenever this thing happens, the area would be half into base into height. Now the ratio of the base of the two triangles is K. The ratio of the height of the two triangle is also K. So I get an answer which is K square. Whenever two triangles are similar, the ratio of their sides is K and the ratio of their areas would be K square. It will be square of the ratio of their corresponding sides. So let me imagine there are two triangles which are similar to each other. The sides of the second triangle being 3 times of the first, the area of the second triangle would be 3 square, 9 times that of first. Question for you. What will be the ratio of the perimeters of the two similar triangles? I'll give you 30 seconds to think about it. What will be the ratio of perimeters of two similar triangles? The areas were in the ratio K square. Their perimeter would be in some ratio. Find out that ratio. So, the ratio of perimeters of the two triangles which are similar would also be equal to K, because all of their sides have a ratio which is K. So what is perimeter? Sum of all the sides. So if you sum up all the sides and add them, you will still get the ratio which comes out to be k. So if you know the ratio of one side and if the triangles are similar, the ratio of perimeters would be k, the ratio of area would be k square. Let's move ahead and let's look at basic proportionality theorem. Basic proportionality theorem says, in a triangle, if a line is drawn parallel to any side, so this DE is a line which is drawn parallel to side BC. What happens in this case is, angle A, if I look at triangle ADE and triangle ABC, angle A is common in both the triangles. If two lines are parallel, AB will act as a transversal. This will be the set of corresponding angles that will be equal. Similarly, AC will act as a transversal and there will be set of corresponding angles which are equal. So, I would write angle D is equal to angle B, angle E is equal to angle C. If all the angles of one triangle are equal to the angles of another triangle, the two triangles are similar. If the two triangles are similar, their sides are proportional and the ratio of their sides would turn out to be equal. How will I write the ratio? The angles which are equal, the sides opposite to those angles would be taken in the ratio. Angle A, in a smaller, it will be D. In a smaller, I'll have DE. In the bigger one, I'll have BC. If I talk about angle D and B, in the smaller one, I'll have AE. In the bigger one, I'll have AC. If I talk about angle E and C, in the smaller one, I'll have AD. In the bigger one, I'll have AB. So, this is how the sides turn out to be if the two triangles are similar to each other. Now, what does the basic proportionality theorem says? If a line is drawn parallel to any other side, it divides the other sides proportionally. So, that means AD over DB is equal to, I'm just taking it here and bringing it there. So, I'll write AD over DB is equal to AE over EC. So, AD over DB is equal to AE over EC. You can prove the same by using similar triangles that we have just done. So, what we have done is, if I look at these two, AE over AC is equal to AD over AB. If you just take if the two ratios are equal, so I'll write AE over AC is equal to AD over AB. If the ratios are equal, right, their reciprocals are also equal. So I will write AC over AE is equal to AD over AB. If the ratios are equal, I can subtract 1 from both the sides and still the ratios will come out to be same. AC minus AE, I'll get EC over AE is equal to AD minus AB, I'll get DB over AB. Again, I can take the reverse of it. So I'll get AE over EC is equal to AD over DB, which is what your basic proportionality theorem is. So whatever is the ratio of lengths AD is to DB, the same will be the ratio of lengths of the other side of the triangle, which is AE and EC. Similarly, the other side that I've given you is there. An extension to basic proportionality theorem is the midpoint theorem. Midpoint theorem says, in a triangle, line joining the midpoints of any two sides. So what I've given to you is, this D is the midpoint of AB, this E is the midpoint of AC. The line joining the midpoint of any two sides is, number 1, parallel to the third side. So a line drawn from the midpoint of the first side and joining the midpoint of the second side would always be parallel to the third side. This is what the midpoint theorem says. And the second thing that I can derive out is the length of this side DE would be half of BC, would be half of the third side, and vice versa. So what is given to me? AD and DB are equal, AE and EC are equal. That means D and E are the midpoints that I have. I will say DE is parallel to BC, DE is parallel to BC, and DE would be half of BC that I have. The proof of which would be given by similar triangles. Triangle ADE would be similar to triangle ABC. Why? Again the same thing, this angle is common, this angle and this angle would be equal because there are corresponding angles. Similarly, the other two angles would be equal. This triangle and the bigger one will become similar. Now I know AD is half of AB, AE is half of AC. So that means the third side would also be half of the other one. Okay. Let's move ahead and let's look at right angled triangle similarity. So if you have a right angled triangle and you have to you draw a perpendicular from the vertex to the opposite side, which is the hypotenuse, what you will get? You will get three triangles. All of them would turn out to be similar to each other. That means the triangle that is formed, this and this are similar, and each one of them is similar to the original triangle that we have. So the angles that will turn out to be equal are this and this. So I will take their corresponding sides, which is AD over DC equal to BD over AD. So if you still have not understood, let's take another case. What I've done, I've drawn this thing. Okay, so let me take this triangle ABC and this side has D. This angle, which is theta, this total is 90, this is 90. So sum of all the three angles would be this. This will turn out to be 90 minus theta. So if this is 90 minus theta, this is theta. This will turn out to be again 90 minus theta, and this will be 90. So I will take the corresponding angles which are equal, theta which is BD and theta here which is DC, 90 minus theta which is AD in this triangle, and 90 minus theta which is BD in this triangle, and I can always solve for the things. So if I just look here and I write it down, I am taking the angle theta, it is BD in the first and DC in the second, equal to 90 minus theta. In the first it turns out to be AD, and in the second it turns out to be BD. So I just cross multiply, BD square is equal to DC into AD. Very important thing that I have in case of a right angle triangle drawn or altitude from the vertex. Now the next topic that we'll cover would be the important lines inside a triangle. This is very important and a little bit confusing in the first time, but gradually you will understand it. The first line that we'll talk about is median. Median is a line joining the midpoint of the base to the opposite vertex. So if I take a line and I join the vertex to the midpoint of the opposite side, that line is known as a median. The second one that we'll talk about is an angle bisector. Now angle bisector, as the name suggests, is the line bisecting the internal angle at the vertex, and it is meeting the opposite side. The third one being perpendicular bisector. Perpendicular line which bisects the base. So that means it's a line which is perpendicular to the base and passing through the midpoint of the base. There is no necessary condition that this perpendicular bisector should pass through the vertex. Don't get confused between median and perpendicular bisector. Median is not perpendicular, but it passes through the vertex. Perpendicular bisector is perpendicular and need not pass through the vertex. Yet both of them meet the base at the midpoint. The fourth one being altitude. Altitude is a line dropped from the vertex perpendicular to the base. It's a line which is dropped from the vertex perpendicular to the base. It does not bisect the base. It is not perpendicular. It is perpendicular to the base. It is not bisecting the vertex angle. So let's look at the figure and we'll try to represent all the four lines in the same figure. Now look at AD. D is the midpoint of BC. If I join AD, AD becomes a median which is from the opposite vertex to the midpoint of the base. AE is an angle bisector. AE is a line which is bisecting the angle A. It is not at the midpoint that we have. So if I look at it, this angle and this angle, AE, if I am talking about, would turn out to be equal. Perpendicular bisector would be ID because it will be perpendicular to the base and bisecting the base. It is not passing through the vertex. Altitude is always from the opposite vertex perpendicular to the base. Let's look at them in greater detail. The first one being the median. Let's look at the figure. ABC is a triangle in which I have taken midpoints of all the three sides. So D is the midpoint of BC, E is the midpoint of AC, and F is the midpoint of AB. Now the midpoints of all the three sides have been joined with their opposite vertex, thereby resulting in three medians, AD, BE and CF. There are three medians that can be drawn in a triangle to three sides. Okay. So if I just look at it, it divides the opposite side into two equal parts. The base is divided into two equal parts. Median always bisects the base. Therefore, an important thing to notice, a median divides the triangle into two triangles of equal area. So if I just look at this triangle and if I draw this as a median, the two areas that you have would become equal. However, the triangles will not be congruent. The two triangles that you get ABD and ADC will not be congruent, but the areas would be equal. The reason for areas being equal is, the formula is half into base. The base for both the triangles is same because it is bisected into height. Now height is from the opposite vertex, so from A till the base BC, the height would not change. So therefore, the areas become equal. The three medians that we have, they are concurrent at a point which is known as centroid, denoted by G. So centroid is the point of intersection of all the three medians of a triangle. If two medians are given, the point of intersection is the point from where the third median will also pass. So it's a point of concurrency of the medians AD, BE and CF. An important property of centroid is that it divides the median, which is AD or BE or CF, in the ratio 2:1. Two parts towards the vertex, one part towards the base. So if I know the length of AD is divided into 2:1 parts by G. BE will be divided into 2:1 parts by G, and similarly this will be divided in the ratio 2:1 through centroid. To find out the length of the median, we'll take the help of Apollonius theorem. Apollonius theorem helps us in finding the length of the median. So let me talk about the case which is AD in this triangle. AD is the median to the base BC, thereby BD and DC are equal. The length, if I have to find, I will apply Apollonius theorem, such as I have to find the length of AD. So AD is between AB and AC. So it will be AB square, this side square, plus AC square equals to twice of AD square, which is the length of the median, plus BC half. Half of BC will be, I can replace it with BD as well, BD square. So AB square plus AC square is equal to twice of the length of the median plus half of the base whole square is what Apollonius theorem is, and it helps us to find out the length of the median if all the three sides of a triangle are given to you. So you can apply Apollonius theorem on all the three medians separately to find out their lengths, and you can add them up to get to a final result. The final result is 3 times the length 3 times the sum of squares of the sides of a triangle. That means AB square plus AC square plus BC square is 4 times the sum of squares of the lengths of the medians. So AD square plus BE square plus CF square. So you can say that the length of median is less than the sum of the lengths of the sides. The second one, angle bisector. Angle bisector means a line which is bisecting the internal angle as already stated. It meets the opposite side at some point. Properties of angle bisector. All the points on the angle bisector are equidistant from the sides making that angle. So if I talk about here, this is angle A. AD is an angle bisector. That means this angle is divided into 2 equal parts. Any point on the angle bisector is equidistant from the 2 sides making that angle. So if I look at the perpendicular distance DC and DB, they'll turn out to be equal. Similarly, if I look at a point D1, it will be equidistant from the two lines making that angle. It's very easy to explain this. It can be explained with the help of congruency of triangles. Now if I look here, this side is common, this angle and this angle is common, this angle is 90 degree that I have. So 2 angles are equal and one side is common. So that means the length is same. The 2 triangles would become congruent. If the 2 triangles are congruent, the other sides would be also equal. Equal means, this length, side length CD and DB will be equal. CD1 and DB1 would also be equal. The property of angle bisector is, angle bisector divides the opposite side in the ratio of the sides containing the angle. This is the angle bisector theorem that we have. So if I just look at it, if I look at the third side as CB and this point as E. So if I look at triangle ABC with an angle bisector AE, the opposite side, which is BC, is divided in some ratio. What is that ratio? That ratio is BE over EC. Now this ratio would be equal to the ratio of sides containing that angle. So what are the sides that contain that angle? BA and AC. Whatever is the ratio of BA is to AC, same will be the ratio of BE is to EC. So what you have is CA over AB is equal to CE over AB. The angle bisector theorem says the angle bisector divides the opposite side in the ratio of the sides containing the angle. Let's take an example. This is what we have, and this is the angle bisector of this angle that we have. Okay? Let me take this side as K and this side as 2K. So this side will also be divided in the ratio 1 is to 2. In center, there are 3 angle bisectors that I can have to all the 3 angles of the triangle. All the angle bisectors are concurrent at a point which is known as in center. So in center is the point of concurrency of the 3 angle bisectors shown as in the figure, AD, BE and CF. Properties of in center. In center is located in such a way that its perpendicular distance from all the 3 sides of the triangle comes out to be equal. It's a property of angle bisector only. Any point on angle bisector is equidistant from the 2 sides making that angle. So in center is a point which is there on all the 3 angle bisectors. So in center has to be equidistant from all the 3 sides of the triangle. Therefore, with in center as the center, you can draw a circle touching all the three sides of the triangle as shown in the figure. Such a circle is known as incircle because it is formed inside the triangle. Here, if you talk about the perpendicular distance, which is IL, would be equal to IK would be equal to IJ, and I'm always talking about the perpendicular distances, right? So here all of them are known as in radius. That means the radius of the circle which is formed inside the triangle. And to calculate the in radius, the formula that we follow is area of the triangle over the semi perimeter. So this will be delta by S. Semi perimeter we have already calculated, A plus B plus C by 2, and area of the triangle you can find out by using any of the formulas, half base into height, Heron's formula, or half AB sine C. You can find the area of the triangle, put it into the formula, and you will get the value of your in radius. Now if I have to apply angle bisector theorem here, I would say if I talk about the angle bisector AD would be dividing the opposite side BC in the ratio of the sides containing that angle. That means AB over AC would be equal to BD over CD or BD over DC, whichever way you want to write. Another thing to remember when you're talking about incenter is the angle which the incenter makes with the base is 90 degree plus half of the vertex angle. So this relationship is what we need to look carefully. Angle BIC is 90 degrees plus half angle A. So this is, if let me say this angle is given to you as 60 degree, this angle will be 90 degree plus half of this angle, so turning out to be 120 degrees. We have just done internal angle bisector theorem. The same thing can be applied to external angles as well. So let's look at external angle bisector theorem. Now, if you look at a figure which is on your right, this triangle ABC, if I extend the exterior angle to angle A and angle C. So this is the interior angle A that we have. This will be the exterior angle A. This is an exterior angle bisector that we have. Similarly, for angle C, exterior angle, this is an exterior angle bisector that we have, and this is the bisector of the interior angle B. Two exterior angle bisectors, they meet at a point which is what? Outside the triangle, because it's an exterior angle. Now this point again is located in such a way that its perpendicular distance from the three extended sides would come out to be equal. So I can again draw a circle touching the two extended sides and the one original side of the triangle. So the rule that is there is this X circle in the circle which is formed inside, X means a circle which is formed outside of the triangle ABC, would follow the rule as B, this is the B that you have, B A dash over C A dash. So that means this A dash is the point, where it cuts the line which is BC. Exterior angle A has to cut BC. If it was interior, it would have cut somewhere here. If it's exterior, it would cut BC at an external point of BC. So it will be BA dash over CA dash is equal to AB over AC. So what are the two sides which are making angle A? They are AB and AC. Since it's an exterior angle, I'll not take BD over DC. I'll talk about BA dash over CA dash. So this there are three sides. This could be done in three ways, and therefore you can get three X circles of this triangle depending upon which side you want to take. The next that we'll be looking at is perpendicular bisector of a line. Now if I look at it, perpendicular bisector means you have a line and you draw through the midpoint a line which is perpendicular to it. So such a line will be dividing the base into two equal parts. This line, the green line L, will be known as perpendicular bisector of the line BC. So it is dividing BC in two equal parts, whereas BD and DC are equal, and this line L1 is perpendicular to BC. Such a line is known as perpendicular bisector. The properties of perpendicular bisector are all the points on the perpendicular bisector of a line are equidistant from the end points of a line. So if I take any point on the perpendicular bisector, let me take this point A on the perpendicular bisector, such a point is equidistant from the end points of the line. So the end points of the line are B and C. So this AB will be equal to AC. If I have to prove it, again I'll prove that the two triangles are congruent because the base is same S, the angle is same A, and this side is common. So with SAS rule, I can prove that the two triangles are congruent. Once the triangles are congruent, the corresponding sides are also equal, and I will get AB equal to AC. Since I have three sides of the triangle, so for all the three sides, I can draw perpendicular bisectors. All the perpendicular bisectors of the triangle will be concurrent at a point which is known as circumcenter. So, circumcenter is the point where all the perpendicular bisectors meet. And circumcenter, therefore, would be equidistant from all the three vertices of the triangle. Let's look at it. This is a triangle ABC that we have, and I have drawn three perpendicular bisectors which are bisecting AB, BC and AC at the points F, D and E respectively. Now all the three perpendicular bisectors meet at a point O. This point O will be known as circumcenter. Now this point has a property that it is equidistant from all the three vertices of the triangle. So OA will be equal to OB will be equal to OC. Therefore, with circumcenter as the center, if I keep my compass here and open it equal to OA or OB or OC, I'll be able to draw a circle which passes through all the 3 points, and that circle will therefore be known as circumcircle with circumcenter as the center. The radius of such a circle will be known as circumradius, denoted by capital R, and will be equal to OA, OB or OC as already explained. Now if you want to calculate the value of this circumradius, that will be given by R equals to ABC by 4 delta. Here ABC is the product of side lengths and delta represents the area of the triangle. So I multiply all the side lengths divided with 4 times the area. The value that I will get would be the circumradius. Angle which the base makes with the circumcenter will be twice the angle which the same base makes at the vertex. So I can say angle at the center is twice the angle at the circumference. Now let's look at the circumcenter position. Circumcenter would not be always inside the triangle. The position of the circumcenter could vary depending upon the type of the triangle is it. The 2 points that we have done earlier, which is centroid and incenter, will always lie inside the triangle irrespective of the type of triangle is it. But circumcenter will not always be inside the triangle. It can be in, on or outside the triangle depending upon the nature of the triangle. If the triangle that I give you is an acute angle triangle, that means all the angles are less than 90 degree, circumcenter will lie inside the triangle. If it is a right angle triangle which is given to you, circumcenter will lie on the midpoint of the hypotenuse. Let's look at a right angle triangle ABC this point I've marked as the midpoint of hypotenuse. This point will act as a circumcenter. So that means if I join this point with all the three vertices, the distance that I'll be getting would be same in all the cases. So OB will be equal to OA will be equal to OC. So with O as the center, I'll be able to draw a circle such that AC becomes the diameter. Now AC will become the diameter for such a circle. This is the circle that I will get, and AC will be diameter of such a circle. In case the triangle that I have is an obtuse angle triangle, circumcenter will lie outside the triangle. Why? Because in an obtuse angle triangle, if you look at it, the perpendicular bisector will not always be inside the triangle. The point of concurrency is not necessary inside the triangle that we have. So I can have it outside the triangle as well. Let's look at the last line that I have inside the triangle, and we are talking about altitudes. Altitude is a line dropped from the vertex perpendicular to the opposite side. That means it is perpendicular to the base and not necessarily bisecting the base. So it's just a line dropped from the vertex which is perpendicular to the base. So let's look at this. If I have a triangle like this, this is a triangle that I have. From the opposite vertex, if I draw a perpendicular to the base BC, this line AD with the height h will be known as altitude. Now in case the triangle that I give you is an obtuse angle triangle, this is an obtuse angle that I have, this altitude would not be inside the triangle, this altitude would be outside the triangle that I have. So let's look at an acute angle triangle ABC and the altitudes being AD, BE and CF. These are the three altitudes that we have. The point of concurrency of all the three altitudes are known as orthocenter. So orthocenter is the point of concurrency of altitudes AD, BE and CF of triangle ABC. Now there's no property that you have for orthocenter. Unlike circumcenter and incenter, orthocenter is not equidistant from the sides, or it is not even equidistant from the vertices. So you will not be able to draw any circle with center as orthocenter, and you will never get a concept of orthocircle because that kind of thing does not exist. So that is the only thing that we need to remember when we are talking about altitudes. Orthocenter is the point of concurrency of all the altitudes, and the angle which the base makes with an orthocenter is related to the angle at the vertex by this relationship. So angle B at C plus angle A is 180 degree that we have. The two angles that we have are supplementary angles. Let's look at some of the special cases that we have. In case of an isosceles triangle, two sides are equal. I will take the unequal side as the base. So if I take this isosceles triangle, this side and this side I am assuming to be equal, and an equilateral triangle. So equilateral triangle, all the three sides are equal. What happens is, if I draw an altitude from this, if I draw an altitude from here, that altitude will be equal to median, will also act as angle bisector, will also act as perpendicular bisector. So in case of an isosceles triangle, if an altitude is drawn from the vertex which joins the two equal sides, that altitude also acts as median, angle bisector and perpendicular bisector. Whereas in case of equilateral triangle, since it is equilateral, so all the vertices, all the angles would be equal, so all the altitudes will also act as median, angle bisector and perpendicular bisector. Therefore centroid with incenter, orthocenter and circumcenter are all the same points. They lie at the same point. Their one is the same. So if I find out the position of one, that same will be the position of all the other 3 points. Another thing that you need to look at is, if perimeter of a geometrical object is given to you as constant, then equilateral triangle will have the maximum area. So what I give you a triangle where the sum of the 3 sides is given to you as constant, And if I ask you, what will be the maximum area that I can draw out with this condition being constant? Then equilateral triangle, when all the three sides are equal, will have the maximum area.